Hello and welcome back if you've been watching the previous ones. If not, then this is a good point as any to start. So let's see what they're asking. Sketch the graph of y is 2 times cos x for values of x between 0 degrees and 360, indicating any coordinates where they meet the axes. I like this. I like this question a lot because, firstly, cos. You might not remember cos easily. I had problems in the past. I've spent so long working with causes that we've become kind of close friends now. So sine is an easy one to remember. It starts from origin. You always hear about in music, tech, or wherever else you go, and they're always banging on and on about sine waves. And think about it. In the real world, how many waves start from the top? Yeah? Think of a string. When you wave a string, I'm waving my hand. It doesn't mean anything because this is a video. When you're waving a string, you grab one end of your skipping rope and it starts from here and you move up and it kind of goes down and then you get a nice sine wave. And that's what sine is. And sine is a version of cos in a way. They're best friends, you know. They're kind of friends in a way. So it's just cos shifted up. So this is my sine. So cos starts where it's 1, so it would go like that. Okay, that's an abysmal diagram, but you kind of get the feel for it. So let's think about what normally it would be. So let me make it green. So we'd start at 1, we'd go down, yeah, then go back up again. We'd be back to where we started. And then they would say, hey, I'll look at my notes just to make sure I'm right. Yep. Initially, this is our 90 degrees, isn't it? Yeah? This is our 360 because it's one full loop, since it would go on like that, on like that. This must be 180 because it's halfway between these 2 points. And then 2 times our cos is pretty much the same thing. I've got an idea. I'll draw it on the same, or near enough, next to it, so you can kind of get an intuition. This should be 1, this should be 1 here. And you'll say, heck, why don't we just double everything? So instead of a 1, we go all the way up to 2 up here. That's a scale. That's a good scale. That looks nice. So you go, wow, all the way back down again, all the way to not 1, but 2 down here. And all the way back up again. And ta-da, there you go. That, I should have drawn my x-axis properly along here. This is 2. This is 90 degrees, isn't it still? Because we haven't moved along. 0. This is 0, 2. This is 270, 0. Yeah, and that is all they want from you, I guess. Yeah, I won't look at marks yet because it might ruin the next bit of the question. Okay, so let's look back at our initial question. So it says here, solve the equation for 2 cos x equals 0.8. So let's have a look. 0.8 would be somewhere here-ish, and think of it as just what the y coordinate would be. So there's 2 ways of doing this. You could either use your calculator or use some trigonometric function to solve this. Wait, no, that's the next part of the question. We just sub this in here, which we could go along and draw a really accurate graph, or we just be lazy bones and say 2 cos x equals 0.8, divide both sides by 2, and then clearly cos x equals 0.4, and we put this into our magical calculator, cos to the -1 or secton, or whichever one it is, and we get 4 is a value of 66.42 degrees. And you say, heck, I like this. But then you say to yourself, heck, they want it between these 2 values. This is 360 here, this is 0, and we've got a point here, haven't we, on our function? We also have a point there, and you go, oh gosh, we can't leave it out because that's about 60, isn't it? It's a third of the way. So you'd say, heck, what's over here? So the distance between this point and this point is 66. So the distance between here must be 66. So 360 minus 66. So I put a little and. If you do English, you'll go, ah, that's a nice semicolon. And then we calculate out 294 degrees approximately. I'm rounding every step of the way like a physicist. I shouldn't do this, but it's good enough for the marks. You might not get the marks fully, so always show all calculations. Never forget that. Okay then, so that's the first I done. So next I, I squared minus 1. You should all do linear algebra when you grow up. Yeah, because it's cool. Okay then, so let's have a look. Solve the equation 2 cos x equals sin x, giving all the values between 180, minus 180 and 180. So you'd say to me, oh, god damn, how does that work? Don't know what I'm doing. And I say, let's have a look. So original question was 2 cos x equals sin x. And you'll say to me, magic, trigonometric identities. And you say to yourself, so katoa. Let's think about it. If we want to get OA, this over this, look, that's the same thing as that, because it's like that, O divided by A. So let's just take these two, because these lot cancel out. They die. Boom. So it's sine divided by sine theta divided by cos theta equals tangent theta. Wow, that's crazy. That's crazy if you ask me. So we divide both sides by cos, so divide by cos x clearly, because we wouldn't cancel down. So we go shum, left with this equals 2. So this is the same thing as tangent, so we just say tan theta equals 2. And we use inverse tan to the minus 1 of 2 to give us what the angles should be. Or we could use radians, but we're sticking to degrees here because they're asking for that. It gives you the value of 63.43. Then you'd all say to me, oh no, but maybe there's a value below 0. And I'd say, wisely done, young one. So you plot a nice graph of thingamajig. It goes like that, all to 90 to 90. And it's just the opposite. It alternates every 180 degrees. Oh, that's an abysmal way of me writing it. Okay, it works. So the next one will be here somewhere. And it works out to be, if you minus 180 from this number, yeah, you will get minus 116.57 degrees. And those are your two answers, and let's have a look at the marks, where they are allocated. Scroll down. Oh, okay. Yeah, labelled. Nice shape of k cos x. So we didn't have to draw the two to compare, but we did anyway. Oh, I won't do the answer for the next question, might ruin it. Okay then, so ta-da. There we go. That's it, we use it properly. Oh, you could square everything, but that's a bit of a longer method to use, and that's it. That's it done. Voila. Hopefully you've enjoyed this video, and yeah, I hope you watch the next one, and if you've got any feedback, please do say so. So yeah, thank you very much.